Okay, so for this example, we are going to be looking at the end behavior of this polynomial. Now, there's a few ways that we can find the expanded polynomial. The first thing that we could do is we could take this really long thing and we could multiply out every single term. Or what we can do is, I see right here that this is squared. That means that this is an x squared. Here's an x to the first and an x to the first. I can just multiply my x's together. So right here I've got x times x times x squared. I really don't care about anything else. Remember what I said. All we care about is that very first, the very first term. So when we have x times x, that's x squared times x squared, which is x to the fourth. So now I know I am dealing with an even. 4 is even, so this is an even function. And now I need to know, is it positive or negative? And for that, I'm going to come right here to the front. There is one negative sign right there. And I look at all my x terms. None of these are negative. There's nothing in front of x that is going to cancel out with this negative right here. So this means that my function is in fact a negative x to the fourth. And if you look back on that chart that we had on the slide before, when I have a negative function where the leading coefficient is negative with an even degree, my end behavior is going to be down and down. So both as x approaches negative infinity, y also approaches negative infinity, and as x approaches positive infinity, y approaches negative infinity. And on the next slide, I'm going to put in the graph of this. Okay, for this slide, we are going to do all the things. The first thing that we need to do is identify any x-intercepts. So that means that we are going to take each term and we are going to set it equal to 0, okay? So each parenthesis set gets set equal to 0, so x minus 1 equals 0, x plus 4 equals 0, and x minus 2 equals 0. We're going to go ahead and add 1 to both sides. 1's cancel, and we have that x equals 1. Come over to the middle problem. We've got minus 4 on both sides. So we've got x equals negative 4. And then last one, we're going to add 2 to both sides. And we will have x equals 2. Okay, we have all those things. So now we are going to look at the end behavior. And again, for the end behavior, we are going to find the order of this polynomial. So I am just going to add my exponents. 6, 10, 9. We're going to add those up. So I've got 6 plus 10 plus 9, and that is 25. So this is an odd degree polynomial, and the leading coefficient is going to be a negative, so it is a negative. If we look back at our graph, at our chart from a few things ago, when we have an odd function with a negative leading coefficient, our graph is going to look something like this, and there will be lots going on here in the middle. But as x approaches negative infinity, ooh, that's really bad, infinity, y approaches positive infinity, and as x approaches positive infinity, y approaches negative infinity. And we can see that as x gets smaller, y goes towards positive infinity. As x gets larger, y goes down to negative infinity. Okay, so we've talked about end behavior. We found our intercepts. Well, those aren't really our intercepts. We found our zeros. And with the zeros, one of the things that we need to know is that there is a multiplicity. And multiplicity are the things that I've highlighted up here in green. Those are the exponents. Those are their multiplicity. When the multiplicity, or the exponent attached to each answer, is even, the graph will touch the x-axis. But if the multiplicity is odd, it will cross the x-axis. So what that means is, I'm going to underline, even, even, odd. So my evens, that means my graph touches at x equals 1 and x equals negative 4. And my odd, oops, odd was blue. Odd's blue. That means that my graph crosses at x equals 2. So when I have my graph, this is going to be so beautiful. I've got my graph. I've got negative 4, negative 3, negative 2, negative 1, 1, 2, 3, negative 5, and that's 3. And so my graph is going to be starting up here somewhere, and it's going to be pointing down here. My graph is going to touch at x equals negative 4, but not cross, so it'll go just touch right there. And it will touch again at 1, and it will cross at 2. So I don't know what's going on here in the middle from negative 4 to 1. Doesn't really matter. But that's what's happening in the middle. We've got our end behaviors graphed, we have our intercept graphed, and we have 2 0 spots where the graph touches at x equals 1 and x equals negative 4. Okay, we are going to do another problem all the way through. First things first, we need to set each term equal to 0. So x to the 9th, we're going to set x equal to 0. X plus 1 equal to 0. 3 minus x equal to 0. And now we're going to solve each little equation that we've started. X equals 0, simple as that. We can leave it. X plus 1, we're going to subtract 1 on both sides. Now we've got that x equals negative 1. And on 3 minus x, let's add x to both sides. And we will have that 3 equals x. Okay, so now we have our zeros. This is where our graph will either cross or touch our x-axis, okay? But before we get that far, let's talk our end behaviors. And for end behaviors, let's see what ordered polynomial we have. We are going to add up all the exponents. We're going to add 9 plus 10 plus 8, and that is going to give us 27. So this is odd. And when we look, we've got a negative x to the 8th, so that'll become a positive x because it's raised to an even power. So our first term will be a positive number. So it's odd and positive. So if we look at our chart, we are going to have a graph that is like that, okay? Our end behaviors will be approaching negative infinity as x approaches negative infinity, and approaching positive infinity as x approaches positive infinity. Okay, now we need to figure out what's going on at each of these points. Now remember the multiplicity, or the power, of each answer that we got up here for x equals 0, -1, and 3. So when x is even, we're going to touch, when the power of x, is even, we will be touching the x-axis. So x plus 1 raised to the 10th, that is even. And then 3 minus x raised to the 8th, that is even. So even, we will touch at x equals -1 and 3. And then we have odd. When the multiplicity is odd, we cross at x equals, and in this case it will be x equals 0. So we will cross at the origin. And if we graph that, we're going to have -1, -2, 1, 2, 3, and we'll just add 4 for good measure. And at x equals -1, we're touching, but we are coming up from, when we look at our end behavior, we are coming up from a negative. So we're going to touch. We're going to have to dip back down to cross at 0. And then we will touch again at 3 before continuing up in a positive behavior. Okay, so our end behaviors, we are approaching negative infinity as x approaches negative infinity. We're approaching positive infinity as x approaches positive infinity. We touch at -1 and 3 on the x-axis, and we cross at 0. Okay, so we are going to use the intermediate value theorem here to show that there is some 0 between two of our x values. Our x values are going to be 1, 2, 3, and 4. And it doesn't really matter which values we're showing. We're showing that there's going to be 2 real zeros between those, but we don't have to say what they are. So what we want to do for this is we are going to take our x values, 1, 2, 3, and 4, and then we are going to take our f of x and we're going to evaluate our function at these values. So, calculator time. When x is 1, f of x is 5. When x is 2, f of x is 0. So this right here is our first real 0. we know that at x equals 2, we have a 0. At x equals 3, we have a -3. We don't consider this a sign change between x equals 2 and x equals 3 because a 0 doesn't really have a sign, so there wasn't a sign change. And then at x is 4, f of x is 2. We do have a sign change between these two. We went from -3 to +2. So what this says, using our intermediate value theorem, when f of 3 is -3 and f of 4 equals 2, there must be at least one real 0 between 3 and 4. And then somewhere in your answer you need to have by the, and I'm going to call it the intermediate value theorem, by the IVT. So we've shown that there's 2 real zeros, just like the question asked. We showed that we have a real 0 at x equals 2, and somewhere here between 3 and 4 we've got a 0. In your answer, you need to say, you also need to include that there's a real 0 at x equals 2 in your written answer. Your written answer needs to include by the intermediate value theorem, and you also need to include this at least one real 0, because really we don't know what all is going on between 3 and 4. We know it crosses the x-axis at least once. It could cross more, so we put in at least one. That's kind of to just cover yourself and make sure that you said, oh, I know for sure there's at least one. I'm also open to the possibility that there could be more, but you only asked me to prove at least 2. I gave you at least 2. Do not ever give them more than they ask for. Okay, so for this problem, we know that we are going to use long division, well, I guess you guys are calling it polynomial division. I always think of it as long division because this is how I learned to long divide. And it's not synthetic. We know that we're not using synthetic because it has a degree 2 polynomial. So right there we know we cannot use synthetic division. So the first thing we do is we set up our long division. Our numerator goes under the division sign and our denominator goes outside. And one of the things about this is when you read any fraction, you can read it as numerator divided by denominator. And then we just divide like before, like we've always learned. We take 4x to the third and we divide that by x squared. Everything else will work out. So 4x cubed divided by x squared, that's going to be 4x. And one of the things that I should have done that I did not do, that was really poor form on my part, was under the radical, give myself a space holder for x to the first power. We're missing that. And that's kind of important right now. So we said that 4x cubed divided by x squared is 4x. So then we'll take 4x and we'll multiply it by x squared minus 4x minus 7. So 4x times x squared is 4x cubed. 4x times negative 4x is negative 16x squared.
4x times negative 7 is negative 28x. And then I always set up my subtraction after that. And I turned negative 16 and negative 28 into pluses because negative times a negative is a positive. Our 4x's cancel. We have 7x squared plus 16x, which will give us 23x squared. And then we'll have plus 28x, and then we bring down the 3, plus 3. Rinse and repeat. How many times does x squared go into 23x squared? That would be 23 times. So 23 times x squared is 23x squared. 23 times negative 4 is negative 92x. And 23 times negative 7 is negative 161. And now I'm going to subtract all those terms. 23x squared minus 23x squared is 0. 28x plus 92x is 120x. And 3 plus 161 is 164. And we have to stop because x squared cannot go into x. We're done. So now when we write this out, we will write our answer in the form 4x plus 23 plus our remainder that we got down here, this 120x plus 164 over x squared minus 4x minus 7. Okay, so again, we're going to divide, and we know we're doing polynomial division because our denominator is x squared. We cannot do synthetic with anything higher than just x on the bottom. So we're going to set up the long division. We'll have x squared minus 5x minus 1 going into 3x to the 4th plus 0x cubed, give myself a placeholder, plus 6x squared minus 5x plus 1. So first things first, we are going to say 3x to the 4th divided by x squared, we'll get 3x squared, and then we will multiply our denominator by 3x squared. So 3x squared times x squared is 3x to the 4th. 3x squared times negative 5x is negative 15x cubed. And 3x squared times negative 1 is negative 3x squared. Go ahead and distribute my negative all the way through. My 3x to the 4th cancels. I am left with 15x cubed plus 9x squared. Bring down my negative 5x and bring down plus 1. And rinse and repeat. 15x cubed divided by x squared is going to be 15x. So I know that 15x times x squared is 15x cubed. 15x times negative 5 squared, 15x times negative 5x is negative 75x squared. 15x times negative 1 is negative 15x. And then I will distribute my negative. My 15x cubed will cancel. I have 9 plus 75, which gives me 84x squared. Negative 5 plus 15 is a positive 10x, and bring down my plus 1. And x squared does go into x squared, so we can rinse and repeat one more time. 84x squared divided by x squared is 84. Multiply those together, we get 84x squared. 84 times negative 5 is negative 420x. And 84 times negative 1 is negative 84. Distribute my negative sign. My 84x squareds cancel. I now have 430x plus 85. So I'm going to write all of this out over here on the lower left-hand side because I didn't leave myself much room. I now have 3x squared plus 15x plus 84 plus 430x plus 85 over x squared minus 5x minus 1. So the answer is all this over here. Okay, we need to divide, and here we know we can use synthetic division because we have a first degree polynomial, or just an x term there on the bottom is a denominator spot. So we know that a 0 is going to go in here, and how we find that 0, we say that x minus 4 equals 0. Add 4 to both sides. It's horrible looking 4. And we get that x equals positive 4. X equals 4 is our 0. Okay? And then we're going to write all of our coefficients. So we've got 1x to the 4th minus 6x to the 3rd plus 0x squared plus 12x plus 0. We need to put in zeros for things that we don't have and for constant terms that aren't there. And when we set this up, our first term comes down, and then we say 1 times 4, and we write it here. And then we'll have negative 6 plus 4 is negative 2. Negative 2 times 4, which is the 0 up here in the corner, which is negative 8. 0 minus 8 is negative 8. Negative 8 times 4 are 0, which is negative 32. 12 minus 32 is negative 20. Negative 20 times 4 is negative 80, which brings negative 80. And this negative 80 right here is our remainder. So that means that we are going to write our answer down as 1x to the 3rd. We're going to drop down 1 power. Okay? Minus 2x squared minus 8x minus 20 plus negative 80 over x minus 4. Okay, so we're dividing another polynomial, and again we know that it is synthetic because our denominator is x plus or minus some number. Our 0 term this time we're going to do in our heads. X plus 3, our 0 then needs to be negative 3. And we're And we're going to write out our constants. We have 6x to the 4th minus 3x cubed plus 12x squared plus 0x minus 7. And we will bring down our 6. And we will have 6 times negative 3, which is negative 18. Negative 3 plus negative 18 is negative 21. Negative 21 times negative 3 is positive 63. 12 plus 63, 75. 75 times negative 3 is negative 225. And negative 225 times negative 3 is positive 675. Negative 7 plus 675 is 668. So we will have 6x cubed minus 21x squared plus 75x minus 225 plus 668 over x plus 3. Important takeaways for synthetic. I don't have a pointer. You need to bring down your leading coefficient, and then it is always whatever's on the bottom times your 0, and then it goes in the spot of the next thing, and then you add your columns. Whatever's there, just add those two terms together. And there are always formulas, and they show you they'll call this B, and then they'll say times 3, and it'll come down and it'll show you times, well, it's negative 3, isn't it? And they'll do it like that. And that's not my favorite way of doing this, but if that helps you, that helps you. So we are multiplying across by the 0 term. Okay, so for the rational root theorem, which is also called the rational zero theorem sometimes, we are going to have P divided by Q, where P is all of the factors of our constant and Q is all of the factors of our leading coefficient. And it's going to be plus or minus all of these numbers. So the first thing let's start with is our factors of 8. So for 8, we have 1 and 8, 2 and 4. And then for 12, we have 1 and 12, 2 and 6, 3 and 4. So this is saying that we are going to take every single term P divided by every single term Q. So strap in, this is going to take a hot minute. And they're all going to be plus or minus. It's an important first step. So I'm just going to start with the first term and work my way through. So I have, my first P term is 1 over 1. I've got 8 over 8, 8 over 1, 2 over 1, and 4 over 1. And then I will move on to, and I'm just going to mark things off as I use them here on the bottom. Next I have 12, so I have plus or minus 1 over 12, plus or minus 8 over 12, but 8 over 12 is 2 over 3. We can take a 4 out of both of those. I've got plus or minus 2 over 12, which is 1 over 6. And plus or minus 4 out of 12, which is 1 over 3. Now I have used 12. Then I have over 2. So I have plus or minus 1 over 2, plus or minus 8 over 2, which is 4. I already have 4 written. 4 is right there, so I'm not going to rewrite it. So that was 8 over 2. And then I've got 2 over 2. 2 over 2 is 1, which I already have. 4 over 2 is 2, which I already have. Okay, great. That was really easy for 2's. So now for 6, I now have 1 over 6, which I already have. 8 over 6, which is 4 over 3. I've got 2 over 6, which is 1 over 3. I already have 1/3. And 4 over 6, which is 2/3, which I already have. Then I have plus or minus 1/3. I already have that. 8/3, 2/3, which I already have, and 4/3, which I already have. And then over 4. I've got 1 over 4, which I actually don't have 1/4 already. That's weird. 8 over 4, which is 2. 2 over 4, which is 1/2. And 4 over 4, which is 1. You can put all of these in ascending order from smallest to largest if you want. You can leave it like this. It's a personal choice. But that's how we find all of the radical roots. And we can use these later for synthetic division, but we're not going to do that right now. Right now we're just working on finding them because that can be a bear in and of itself. Okay, again, we are going to find all of the radical roots of P, which is 9, divided by Q, which is 16. So my factors of 9 are 1 and 9 and 3 and 3. We only have to write each factor once. For 16, I've got 1 and 16, 2 and 8, and 4 times 4. Now to find my factors, plus or minus the top divided by the bottom. So first things first is everything on top divided by 1, which is nice and easy enough. Now everything on top divided by 2, plus or minus 1/2, plus or minus 3/2, plus or minus 9/2. Now everything divided by 4, plus or minus 1/4, plus or minus 3/4, plus or minus 9/4. Everything divided by 8. Oops. Everything divided by 8, so we've got plus or minus 1 over 8, plus or minus 3 over 8, plus or minus 9 over 8. Now everything divided by 16. Oh my gravy. Plus or minus 1 over 16, plus or minus 3 over 16, plus or minus 9 over 16. And that is everything. So there were no repeats in this one. Everything was present only once. Okay, so you've got your rational root theorem, which is fine and dandy, but what do you use it for? We use it when other forms of factoring have failed us, when we cannot figure out how on earth to factor something. So again, we're going to have P divided by Q, where my P is 32, and my Q in this case is 1. So that's pretty easy for this one. We are just going to have plus or minus all the factors of 32, which are 1, 32, 2 and 16, 4 and 8, which we could rewrite plus or minus 1, plus or minus 2, 4, 8, 16, and 32. Now, what are we doing with these? We want to find our zeros. We want to make some nice ordered pairs and figure out what is going on. How are we going to factor this? And so to do that, we are going to do synthetic division. But for the zeros, we're going to pick one of these rational roots that we found. And this really is just a matter of plug and chug. So you're going to put some 0 up here. You have 1, 2, negative 16, negative 32. And then you just pick your favorite 0 and you go through this. So I'm going to pick 2 because why not? I want to come down. 1 times 2 is 2, which is 4. 4 times 2 is 8. Negative 8. Negative 8 times 2 is negative 16. That is not 0, so I know that 2 is not one of my rational zeros. So I am just going to cross out positive 2. And I want to know if negative 2 will work. So I'm going to repeat this with a negative 2. So 1 times negative 2 is negative 2, 0. 0 times negative 2 is 0. Negative 16. Positive 32, which is 0. So then I know that a 0 is negative 2. And we are just going to keep repeating this until we have found all of our zeros. I'm going to try it with, what should we try? Let's just try 1. Let's just be boring and we'll go through them all in order. So 1 times 1 is 1, 3, negative 13, negative 13, that's a number. So positive 1 is off the table. And it really just is meant to be gone through super quickly. Where we're just going through, and whatever we find right here, if it's 0, it's a 0. If it's a number, and really, in this column, once you see that that's not going to zero out, you can just stop. You don't have to go all the way through. So negative 1, 1, negative 1, negative 17, positive 17, stop. Didn't work. And just get rid of it. Let's see, we've got negative 4 and 4. So 1 times negative 4, negative 4, negative 2, positive 8, negative 8, positive 32, that's a 0. So negative 4 is a 0. And let's see if positive 4 works. And I'm just going to mark negative 4 off my list here. Already used him. Positive 4. 1 times 4 is 4. 4 and 2 makes 6. 6 times 4 is 24. 24 minus 16 is 8. 8 times 4 is positive 32, which is also 0. So both positive and negative 4 are zeros. And let's see, this is x to the third, so that means that there's only 3 zeros. I'm only going to have 3 x terms. So let's go over to the next slide. Well, let me make sure I have this written down before we go to the next slide, because that would be bad if I didn't know what was going on. Okay, so next slide, and we had f of x equals 1x cubed plus 2x squared minus 16x minus 32. And we had said that our zeros, which I'm just going to call z, were negative 2, negative 4, and 4. And so I think that if I've got x minus 2, but it's going to be the opposite, so x plus 2, x plus 4, and x minus 4. Well, I know when I have x plus or minus something, this is going to be x plus 2, and then this will give me x squared minus 16. And now I can FOIL out. I'll get x cubed minus 16x plus 2x squared minus 32, which is what I had. So other factoring methods failed me. I can use my rational roots theorem to find the number of zeros, and remember the number of zeros will not exceed your leading exponent. I can only have that many zeros. Once I find them, I stop and take the opposite sign when you put them back in. So we had a negative 2, we had to put it in as a positive 2. Okay? And then I always just check myself because I want to make sure that I'm actually doing the right thing and I know what's going on. But that is an example of how to use your rational root theorem.